Hello friends! In this video, I will explain the basic working logic of IGBTs, their features, and where they are used. The name IGBT comes from the abbreviation of the initials of the English words insulated gate bipolar transistor. It is a power electronic circuit element formed by the development of the best features of the MOSFET and BJT transistor. It appears in many areas used for switching purposes. IGBTs, which can act as triacs or transistors when needed, are used extensively, especially in UPSs that require high switching speed. The IGBT is the combination of BJT and MOSFET. Its name also implies the fusion between them. Insulated gate refers to the input part of MOSFET having very high input impedance. It does not draw any input current, rather, it operates on the voltage at its gate terminal. Bipolar refers to the output part of the BJT having bipolar nature, where the current flow is due to both types of charge carriers. It allows it to handle very large currents and voltages using small voltage signals. This hybrid combination makes the IGBT a voltage-controlled device. IGBTs have 3 pins. One of them is the gate, the other is the collector, and the last one is the emitter. The abbreviations G, C, and E are used for these. Their locations may not always be like this. Pin locations may change according to the type. Their symbols are as you see on the right. These 2 symbols are also used. You may encounter symbol drawings similar to these that differ slightly. As can be understood from the pin names, we can understand that it shows both MOSFET and BJT transistor features. If you remember, the gate pin is located in the MOSFET, while the collector and emitter pins are located in the BJT transistor. The working logic is similar to the working principle of the same MOSFET. With the trigger voltage applied to the gate pin, a large current between the collector-emitter is controlled. In other words, as in the same MOSFET, current control is provided with voltage. Now let's look at the advantages and disadvantages of IGBTs over BJT and MOSFET transistors. As a whole, IGBT has the advantages of both BJT and MOSFET. If we start with the advantages, it has higher voltage and current carrying capabilities. It has a very high input impedance. It can switch very high currents using very low voltage. It is voltage controlled, meaning there is no input current and input losses are low. It has a higher power gain than both BJT and MOSFET. It has a higher switching speed than a BJT. Disadvantages? It has a lower switching speed than MOSFET. It has a locking problem due to its PNPN structure resembling a thyristor, and it is more costly than BJT and MOSFET. These were the prominent advantages and disadvantages. So where are IGBTs used? Now let's look at where they are used. IGBTs have numerous applications used in AC and DC circuits. Here are some of the important applications of IGBT. SMPS, or switched mode power supply, is used to power sensitive medical equipment and computers. These devices regularly supply power to electronic devices. It is used in the UPS, or uninterruptible power supply system, that provides energy during power outages. UPSs store energy in batteries when there is electricity. When there is a power outage, the DC electricity in the batteries is converted to AC and used in electrical devices. Similarly, it is used in inverter circuits that meet the need for power conversion, which we can encounter in many places. It is also used in devices known as solar inverters. Solar inverters provide the conversion of the energy in solar panels to be stored in batteries and then used in devices at home. These are the basic structures of IGBTs and where they are used. I hope you liked this video and it is useful. Hope to see you in the next lesson. Goodbye!